All right. Hello. I am back for our next lesson. So today we are talking about properties of real numbers. So it says 1.11 because it should have gone in the Unit 1 lessons. Unit 1 was mostly review for the things that you should have learned last year in your 7th grade math classes. Some of you probably learned some of the things and maybe forgot or whatever the case was. But properties of real numbers should have been one of the lessons in Unit 1. And I know we've moved on to Unit 2 where we've talked about simplifying expressions and combining like terms. Sorry. Combining like terms. So as we move further into Unit 2, it's going to be important that you remember some of these properties of numbers that will help you solve one-step equations, two-step equations, right? And so I thought it important for us to review this lesson and you to do a little bit of practice to make sure that you understand it. And I will probably give you another practice sheet maybe on Friday, just again to make sure that you know and understand these different properties of numbers. Yes, because it will help you as we move forward. That's the goal, and that's what I wanted to state. Oh, excuse me. Let me get myself together here. Okay, so that you can see me. So I'm not at my desk, and so I can't prompt the tablet so that I can write and you can see me. So there might be times where I zoom in and zoom out of my face, but I think I can move my face upward. Can I? Oh, look at me. Can I go up? Oh, wow. That's a lot better. Yay. Okay. So here we go. So properties of real numbers. In math, properties are statements that are true for any number. They justify steps when simplifying expressions and solving equations. All these tools that I keep giving you are just tools for you to be able to solve these problems, like I tell you, like I explained. So in math, there are rules that we have to follow. In math, there are rules that we have to follow. We can find an easy road to get to the end, right, for the answer. Sorry, it feels weird. Oh, because the camera's right here. Okay. We can find an easy, quick road. Sometimes there's bumpy roads and curvy roads to get to the answer, but nonetheless, we can bend the rules to help us solve a problem. But you can't not apply the rules. You just have to apply them so that they work consistently as you solve math problems. We are consistently reminded when we do different activities that you have to find common denominators when you add or subtract fractions, right? No matter what problem you get, no matter where you run into a fraction where you have to add or subtract, you have to somehow apply that rule. Whether you are quicker at simplifying the fraction first or finding the common denominator, whatever pathway you take, you can't skip or ignore the rule to get to your answer. Otherwise, you won't get to the right answer. All right. So I said all that just to kind of remind you that some of this maybe seem redundant or I'm repeating myself over and over again, but that's all that math is. Math is patterns, looking for patterns in numbers, and when you find those patterns, using those patterns to help you solve a problem. That's it. That's really what math is. Consistent patterns over and over again. Repetition of the things that you know, how you can apply it, what you can do. All right, I've gone on my 4 or 5 minute spiel. Let's get started with properties of real numbers. This should be an easy lesson, maybe a lot more writing than we're used to, but nonetheless should be fairly easy. Okay, here we go. So I've already read the little steps up here. So the communicative property, I think I talked about this in another lesson. The communicative property, the main idea here is that the order doesn't matter with addition or multiplication. Can you guess why addition or multiplication? I'm pausing to see if you have figured it out or if you thought about it. If you think about the connection between addition and multiplication, Multiplication is just repeated addition. That's it, right? If you add 2 plus 2 plus 2 plus 2 plus 2, we can simplify that problem by saying 2 to the 5th power, right? Or 2 times 5. Sorry, not 2 to the 5th power. Sorry, that's wrong. If you do 2 plus 2 plus 2 plus 2 plus 2 plus 2, however many 2's you have, you can do 2 times however many 2's, and you will still get the same answer if you're adding. For example, 2 plus 2 is 4, so we can do 2. Uh-oh, my pen's not working. Oh, look, I'm fancy now. Oh, man. What color are we going to do? Let's do something you can see. Let's do purple today. We're going to try it. So if you do, let's say you do 2, I'm just going to do an example up here. Plus 2 plus 2. And that will give us 6, right? 2 plus 2 is 4. 4 plus 2 is 6. Or multiplication is just repeated addition, simplified. We can do 2, right, is our base number, and there are 3 2's. 2 times 3 is 6. So the reason why the communicative property, I did all that to show you that the reason why the communicative property works with addition and multiplication, and the order doesn't matter, is because it's just repeated, right? Multiplication is just repeated addition. So the main idea here, sorry, I have to drop it so I can write a little bit, is, no, stay with me. The main idea is that the order does not matter. The order of the equation. Should I write that? Does that make sense? Oh, excuse me. Order Oh, I don't want to say that. That's actually not so. Sorry about that. Sorry. I don't want to start this video over. Order does not matter. Does not matter with addition and multiplication. Okay? Multiplication. I'm pretty sure there's something missing in that. Too many I's. Multiplication. Okay. You know multiplication. Okay, so the order does not matter with addition and multiplication. Here are some addition examples. I use the number 2, but if we just use variables, right, like AB or XY or RS, any 2 numbers next to each other would suffice. Y and Z works, or X and Y. Okay, so if we do addition, we can do A plus B is the same as B plus A, right? If it were 2 plus 3, right? 2 plus 3 is the same as 3 plus 2, right? You're going to get the same answer. So that's with addition. Let's put some numbers in there. Oh, look at me. I already jumped ahead of there. I was going to use 6. We'll do 6 plus 7 is equal to 7 plus 6. There you go. Since I already used 2 multiple times, I figured I'd use a different number. All right. The same thing goes for numbers with variables. If you have a number that has a variable attached to it, it's the same thing. So we can do, let's do 3x plus 5 is the same as 5 plus 3x, because no matter what x is, if we multiply it by 3 and then add 5, following our order of operations, we're still going to get the same answer. All right? We can do another one. Would be like, let's see. Let's do x and y. So let's do y plus 8x is the same as 8x plus y, right? There you go. No matter what x is, once you multiply it by 8, you're going to add y after. No matter what order that goes in, you have to do the multiplication first, then add. So you can rearrange the problem to fit your needs. All right, let's try that with multiplication. I bet it's the same. Let's do A times B. I'll put a little dot. Times B is the same as B times A. Let's add some real numbers, of course. Let's do, we could do, actually, let's do, let's do 4A times B is the same as B times 4A. I should have used different letters, but it's okay. Right? It's the same. You're going to multiply what A is times 4. Then you're going to multiply whatever that number is times B. Right? In whatever order it comes in. So multiplication is you're going to multiply no matter what. They're both multiplication. 4A is a multiplication problem, and then times B is a multiplication problem. All right, let's do a different one with variables again. We could do negative 5 y times, I don't know, 9 is the same as 9 times negative 5y, right? We're just moving the numbers and variables around, but we're still doing multiplication in the problem, and we're still doing it left to right, whichever one comes first. We're going to end up with the same thing. All right, and the last one, let's say add one of like the distributive properties we did. Let's do B plus C times, what number have I not used? 2, 3, 4, 5, 6, 7, 8, 9. Let's do 2. Is the same as 2 times B plus C. Okay? Following the order of operation when it comes to addition and multiplication, the order doesn't matter. When it comes to all addition, right? Here is all addition, right? It doesn't matter which addition you do first. They're going to end up the same. But you don't do addition before you do multiplication. You always do multiplication first when it comes to the order of operation. So I don't mean that you can do addition in an order of operation before you do multiplication. That's not what I meant. I meant that changing the order of the numbers will still land you the correct answer. It's just moving the numbers around. Okay? All right, let's move on. Sorry, we've got lots to write, so let's move on. Now we have the associative property, and the associative property has to do with grouping. Oh, there's one thing I wanted to tell you about communicative property. For me, I remember when I learned this when I was younger, communicative, right? That's when you talk to someone. I try to think of it as being people, right? I can communicate with my brother, and I can communicate with my sister, right? So it doesn't matter who I communicate with. I'm the common variable. I'm communicating with one person first, then I'm communicating with another person, right? If I communicate with my sister before my brother, doesn't mean I still can't communicate with my brother before my sister next time, right? So it's communicating one before the other, but you're still communicating. So that leads me into associative property. So associative property is like grouping, right? You're associating people together, right? An idea behind that would be we associate the math teachers with the math teachers, and we associate or group the science teacher with the science teachers, or the reading teachers with the ELA teachers with the ELA teachers. In social studies, we try to cluster them or group them together according to their subject. So the associative property is grouping. Grouping doesn't matter. matter with addition and multiplication. Look at me getting better with my writing. Oh, I didn't do it in the lines though. Okay. So like if you think about one side of the 8th grade hallway has math teachers. We're all grouped together, right? Our classrooms are all next to each other. And then you have a little gap, and then you have the reading teachers at the end. Or if you think about it, the science teachers in the 8th grade hallway are in the middle together. And the computer science teacher, Miss Gregory, Mr. Pavlik, they are grouped together next to each other. Same thing with social studies teachers, Miss Blakemore, Miss Guy, Miss Connors. I can't think of the new teachers' names, but they are all grouped together on the side. So you can group different numbers and it will still get you to the right space. All right, here we go. Ooh, we're already at 16 minutes. We're going to go a little bit faster. Okay, so we have, let's use numbers like grouping. We're going to use parentheses to group things together. So we have like 8 plus 9 plus 7, right, is the same as leaving the 8 out this time and grouping plus the 9 plus the 7. It's still the same. You're still going to get the same answer, right? So you have 8 plus 9 is 17, and 17 plus 7 is 24. And let's try it over here. In parentheses, 9 plus 7 is 16, and 16 plus 8 is 24, right? So we can group things together and still get to the right answer. Sorry, this weird me writing down that way. All right, so that's like grouping, right? You can group people together. They're still all the same, right? It's still all going to get you the same response. All right, here we're going to do it with variables. Let's say we have x plus y grouped together plus z is the same as x plus y plus z. Same concept, just changed it to variables. All right, and then let's add some numbers to our variables, our letters, right? So let's say we have 7a. Sorry, I took some notes. 7a plus 2 plus y. I don't know why I mixed those letters together. It's really strange. Is the same as if we do 7a grouped together plus 2 plus y. Same thing. I'm just regrouping the variables. All right. And then let's do one more. We have 6 plus, I don't know, 3b plus 4, right, is the same as leaving 6 by itself and then adding that to whatever 3. Oh, wait, I already did that. Sorry. It's the same as grouping 6 plus 3b together plus 4. Still going to get to the same destination. All right, let's do that with multiplication. Same idea. We're going to use variables. A times B times C is the same as A times B and then times in C. All right. Let's add some numbers. Let's use 6, 7. Let's use 2, 3, 4, 5. Let's do 5 times 2, 3, 4, 5, 6, 7, 8, 9. Let's do 5 times 2. Whoops, group it times, I don't know, 3. And then we can, sorry, I'm too loud, I'm waking people up, is the same as 5 times 2 times 3. All right, let's see if that works. Let's do the parentheses first because the order of operations says we have to do parentheses first. So if we do this first, we have 2 times 3 is 6, and 6 times 5 is 30. Let's look on the other side. 5 times 2 is 10, times 3 is 30. Okay, so it works. Okay. All right, sorry, I had to press pause. I'm back. I'm a little too loud. Okay, so then let's try another one. Let's do 6x times, I don't know, 2y times, I don't know, 4 is the same as grouping 6x times 2y times 4. All right, we're still going to get to the same destination. All right, let's do an even more complicated one. Let's say we have 4a times, I don't know, 3b times 5c is the same as grouping 4a times 3b together, then multiplying that by 5c. There we go. All right. I'll keep moving on. I'm already at 20 minutes. We still have 1, 2. Ooh, well, not too much. Okay. The identity property. But anyway, I'm going back to just share that associative. Think of groupings of people. Think of subjects. People who teach the same subject are grouped together. All the principals are grouped together, right? Or the PE teachers are grouped together because they are associating people with likeness. Okay. All right. So the identity property, I'm pretty sure I mentioned this in one of our previous lessons, hopefully that you watch. And the identity property, the main idea here is that you keep the value of the number. So we're going to keep the value of the number. All right, keep the value of the number. Whatever the number value is, we have to keep that. So we can do anything to the number when it comes to addition and multiplication, but the value of the number has to be the same on the other side of the equation. For example, we could do with addition, we could do 9 plus 0 is going to equal 9, right? The value of 9 didn't change. That's called the identity. Identify with myself, right? Whatever myself is, I'm identifying with that, okay? We can do that with variables. X plus 0 is equal to x. We didn't change anything about x. We can do that with numbers with variables. We can do 3a plus 0 is the same as 3a, right? And then we can do even more complicated ones. We can have negative 7r plus 0. It will equal negative 7r, right? We didn't change the value of the number on the other side of the equation. It's called the identity property. So for multiplication, we can't do 0, can we? No. Do we know what number we have to use with multiplication? Hopefully you know. Anything multiplied by 1 will always give us that number again, right? So with multiplication, we're just changing the 0 to a 1. So we can have 8 times 1 will give us 8. The value of the 8 didn't change. Sorry. I'll be right back. Okay, I'm back. We can do this with any numbers. We can also do this with fractions. We can have 1/3 times 1 will equal 1/3. Whatever that number is needs to be the value. It needs to identify with itself on the other side of the equation. We can add variables to numbers. Let's do 4x times 1 is equal to 4x, right? And we can then do negatives. Negative 28 times 1 will equal negative 28, right? The value of the number didn't change on the other side. That's the identity property. The way I remember that is that it must identify with itself from one side of the equation to the other side of the equation. It still has to be the same identity. All right, here we go. Ooh, we're getting up there in our numbers. I try to keep our lessons about 30 minutes. Might be a little over 30 because I talked for the first 5 minutes. All right, you can go back and pause this if you need to pause the record, but I'm going to keep moving forward so that we can get to it and zoom in a little bit. All right, here we go. So the inverse property, it uses the opposite of what it is that's there to cancel it out. That's the main idea of the inverse. It's like a reverse, like doing the opposite of what it's asking to do. Okay, so the main idea is that it uses the opposite. Make sure I say this right. Uses the opposite to cancel out. All right. Those are just my extras. You don't have to put those. All right. For example, right, we're doing the inverse. Whatever it says to do, we're going to do the opposite or the inverse of that. For example, we have 10, right, plus an inverse would be, what would be the opposite of 10? Negative 10. Yes, plus negative 10 will give us 0, right? Again, it's doing the inverse of what it's asking. So let's do a fraction. We could do 1/4 or negative 1/4 plus positive 1/4, which will cancel each other out. All right, let's add some variables. Obviously, we can do let's do v plus negative v, whatever v is, the opposite of that will cancel each other out. Yeah. All right, and then we have, let's do negative 3x plus positive 3x will cancel out each other, right? So we have the inverse property. All right, so let's try that with multiplication. Obviously, we can't use 0, or we can't just do it with adding, right? So perhaps you'll figure it out here in a second. Let's try it. Let's do 8, right? Positive 8 times, what will cancel out this whole number 8? What can we do to get rid of 8? You can't multiply it by negative 8 because that's just going to give us a bigger number. We need to do something. What's the opposite or the inverse of multiplication? Hopefully you said division, right? Multiplication makes numbers bigger. Dividing makes numbers smaller. I think I've talked to you about this. Dividing is breaking things into pieces, making them smaller, whereas multiplying or get more is making things quite large, right? So the inverse of 8 times 8 is a whole number. We would probably need to multiply it by its opposite. So we're going to multiply it by a fraction, because fractions aren't whole numbers. So if we multiply this by the inverse, the opposite of 8 is 1/8. Oh, which will cancel each other out. You need me to show you really quick? So 8 is a whole number, but if we put it over 1, it's still 8 times 1 over 8. Oh, I'm sorry. And it shouldn't be 1. It should be 1. Okay? If we cross multiply and just do 8 over 8, that's still 1. Or we can cancel the 8's out here, make those 1's, and 1 times 1 is 1, and 1 times 1 is 1. We still get to 1. Okay, so it's the inverse. And it shouldn't be 0 with multiplication. It always should be 1. Okay? All right, let's try it with a fraction to start with. What if we have negative 1/2 times, what's the opposite of 1/2? Right, it would be a whole 2, right? Which would cancel each other out, which would be 1. All right. Let's do, I don't know if we can do these with variables. Maybe. My examples don't have variables, but I'm not sure why. Okay, so we could do, let's do 6 times, yes, sorry. It should be negative for both because 2 negatives cancel each other out. I'm so sorry. I had like a brain moment of doing that. Okay, so the opposite would be not negative. I'm having pen trouble here. 6 will give us 1. Right? 2 negatives have to be in an equation in order to give us 1. The reverse or the inverse. And then let's do 2 fractions. So what about 5? No. Oh yeah, 5, 6 times, what would be the inverse or the opposite? Yes, it would be 6/5. And they would cancel each other out. These 6's would cancel on these 5's and we would still get 1. All right, let's move a little quicker. I'm getting closer to the 35 mark. If you need to, you can stop and pause so you can copy this, but I'm going to move quickly so I can get through it. All right, property of 0. So this is anything multiplied by 0 equals 0. It's the property of 0. Anything multiplied multiplied, I spelled that wrong, multiplied by 0 is 0. Okay, perfect. This one's super easy. Let's say we have 5x times 0. Whatever 5 times x is, when we multiply that left to right, order of operation, left to right, we would do this multiplication first, and then whatever we get here times 0 will give us 0. Period. Equal. I mean, not equal. Easy is what I meant to say. All right, let's try like a complex one. Let's do a, b times c times 0. Yes, we do whatever's in parentheses first, order of operation. And then whatever we get from inside the parentheses, when we multiply that by 0, we get 0. All right. Next up, distributive property. We just went over this one. Your last lesson, I think on Thursday, covered distributive property. So you should know what the main idea here is multiplying. Sorry, that was for my pen. Multiplying a value to an expression in parentheses. Theses. Okay. Sorry. It's a complex word. All right. So some examples. We've done these. These should be easy to come up with. You don't need mine. You can come up with your own. But we'll do an easy one. Let's do 5 times x plus 4 is equal to, and we distribute, right? We would distribute 5 here, and we distribute 5 here, and that'll give us 5x plus 20. Right? All right, let's try it with just variables. Let's do a times b plus c. That will equal, remember a is distributed to both. I don't know why that did that. That was a pretty cool thing. That means it's AB plus AC. Ooh, that's an ugly C, but you know what I mean. All right. Let's do another one. Let's do negative 9 times, I don't know, x minus y, right, is equal to, we're going to distribute negative 9 here, and then we'll distribute negative 9 here, and we'll keep the sign. So negative 9x, ooh, but we have negative and a negative, which should equal a positive, and then plus 9y. All right. And then let's do one more. Let's do a weird fraction. Let's do 1/2 times 20 minus 3. Did I use 3 yet? I did not. Is, what's 1/2? Remember, we're distributing 1/2 to this, 1/2 to that. No, I didn't mean to do that. Sorry. Let's do 20. Let's add a variable because we need a variable. 20x minus, did I say minus? No, I don't want to convert minus 3. All right, so half of 20 is 10, right? And half of, ooh, let's do a better number so we don't have any decimals. Can we do 6? There we go. Okay. And then half of 6 is minus 3. There you go. 1/2 of 6 is 3. I just want a cleaner number. Sorry. All right. Now, the last part is just to name that property. And you can go back and look at the names of different properties to see what's happening here. But I can tell you right away, and we're going to do them together. Right now, I see adding, and I see different groupings of numbers with adding. And I know that that has to do with grouping people together that do the same thing, right? Or I can group people a certain type of way. So I would say that this is associative, right? I'm associative. I'm going to do that. Property of addition. Okay? Because you're grouping numbers together or grouping things together with adding so that they turn out the same way. All right. I see one side, it's 2 parentheses x plus 9 is 2x plus 2 times 9. Ooh, we just did that one. That one's the distributive property. I'm just going to put prop. All right. Ooh, automatically I see a 1 in this one, so I know this has to do with the identity property, right? That whatever the value is has to be the value at the end. So this is the identity property. Let's make sure. Yes, it's where the value is the same. So it's the identity property. I tried to do it without looking. Identity property. I'm going to put prop. Okay, let's do it without looking. Let's see if we can do the rest without looking. All right, I see n plus n is the same, plus 3 is the same as switching. N plus, oh, excuse me, is the same as switching. N plus 3. Oh, excuse me. And we talked about that I can communicate with my sister, and then I can communicate with my brother, or I can communicate with my brother first, and then communicate with my sister. So I know this is the commutative property. property of, and it looks like they're using addition. I'm just going to do short, sorry. All right, and then the next one, I see a 0 right away. I know that this is the 0 property, right? Because anything multiplied by 0 is 0. All right, number 6, I see they just regrouped things together in a different way. So they started off with 7 on the outside, and I know what you're thinking. This can be the distributive property. It could be if on the other side they actually distributed the 7 to the numbers, but they did not. So I think what they did here was they just communicated differently, right? Remember, you can communicate, like 7 can communicate with W, or 7 can communicate with 3, or you can make 7 communicate with 3 first, and then 7 can communicate with W over here, right? They just communicated them differently, or they moved the 7. So this is communicative, right? Commutative prop of multiplication. They just moved the numbers around. So they communicated differently. All right, name the additive inverse of 16. The additive inverse. So if we have 16, the inverse of 16 would be a fraction. So name the additive. So it would be, oh, no. The additive inverse would be negative 16. We don't have to do a fraction, because if we take 16 and we add negative 16, we cancel each other out. All right, and the last one, name the multiplicative, oh, is there more? No. Multiplicative property, or name the multiplicative, that's a hard word for me to say, inverse of 3/7. That would just be the inverse, right? The opposite. We would flip it, so it would be 7/3, I believe. All right. I talked a little long on this one. I tried not to make it super long. I truly apologize. My goal is to always keep it about 30-35 minutes so that you don't get bored too quickly listening. Or if you're not listening at all, you're just following along copying, that works too. But sometimes I say things that are important for you to hear, so it's good if you do listen to me. All right, that's the end of this lesson. Again, super easy. It's just going to help us further down the line when we get into the next few lessons that are coming up this week. These properties are going to be important for you to apply with those lessons. All right, have a great day. I will see you in the next lesson.